Now we're going to look at a little bit more practice with these potential differences. And in this example, we're going to look at a dipole. So a dipole has, again, a positive charge and a negative charge. So the positive charge is under here somewhere, and the negative charge is going to be in about here in this particular diagram. And for a positive charge, we have large positive voltages close to the charge. And for the negative charge, we have large negative voltages around the charge. And so in the area between these two charges, there is a point where it's zero. So that's zero here, zero voltage here, and here is our line of zero voltage in this diagram. So there's both diagrams. Obviously this one's going to be easier to draw on paper because it's just circles. And here we have the electric field lines, whereas this gives you good representation that if I have a positive charge on this, it's going to roll all the way down this hill and into this well to be near that negative charge. And if I have a negative charge, it's going to do exactly the same opposite. So these are arbitrary units. I guess I should have labeled that as a +2, but it doesn't matter. So the two charges have equal magnitudes in a dipole. There's a large gradient, and if we were to think about this as a topographical map, then in a topographical map, the closer the lines are, the steeper the slope is between the elevations. And the voltage, is the positive charge is positive, the voltage around a negative charge is negative, and we do have this area in between where it does go to zero because that's the number between positive and negative. So voltage is another example of superposition, as are all the other properties we've talked about as well. So now here's a chance for you to get some practice with this, looking at these diagrams and figuring out which locations have a higher potential or a lower potential. So for each diagram, figure out which point has the highest. That means largest and most positive, not just the largest value, but largest and most positive potential. So pause this video while you figure out the answers, and then come back to it when you have a good guess. Okay, so welcome back. So here we want to look at this positive charge. We know that the largest and most positive is going to be nearest the positive charge, and it looks like 1 and 2 are equidistant from the positive charge, so those are going to have a larger potential. So we would say that 1 is equal to 2, and they are both larger than 3, since 3 is farther from the positive charge. Now we're looking at a negative charge. These two again are the equidistant, but they're going to be negative. So we're going to say those are like both -10, and this is -5. So this is actually going to be the larger potential. So here we have 3 is going to be a bigger value because it's less negative than 1 and 2. Okay, now we have two charges, a single positive charge and a double negative charge. So this is plus Q, and this is minus 2Q. So which has the most positive and largest value? Now 2 and 3 are equidistant from our positive charge, but 2 is also close to this negative charge. So again, we're going to have a large gradient in here. So that's actually going to probably be a negative voltage of some sort, where this one is going to be a positive voltage because it's farther away from the negative charge. So 3 is going to be bigger. So here we would say 3 is going to be the biggest, which is what we care about in the answer, but that's going to be bigger than 2 and bigger than 1. Now if we're going to look at these two charged plates, then 1 and 2 are equidistant from that charged plate. So they're going to have the same potential. And so 1 is going to be equal to 2, which is going to be bigger than 3 and 4, and those are going to be the same because they're equidistant from that plate. Now this diagram is a little different because here we have the electric field lines and they're moving that way. So we're going to know that the positive charge is here and the negative charge is probably over here. So we might have multiple positive charges to have this kind of strange shape, but the shape doesn't particularly matter. It's just that to have a lower potential, so again, the potential line is going to be perpendicular to these lines. So the potential lines are going to run something like that. But the point 1 is going to have a higher potential. So we're going to say that's 10 volts and 5 volts and maybe 0 volts here. And then we maybe get into negative volts here. So -5 volts when we get down here. So 1 is going to have a higher potential than 2. It's going to have a higher potential than 3. because of the orientation of those electric field lines.